In the last video segment, we looked at a graph of data like this, and we asked questions like, what is the smallest number in the list, and what is the largest number in the list? Now, let me ask you a question that sounds funny, but it's actually really important. What is the mediumest number in the list? Is there such a thing? Well, there's a whole subject of statistics devoted to answering that question. It's called measures of center. Measures of center are one of the topics in how we summarize data. So let me kind of briefly explain why summarizing data is important. Remember that data means long lists of numbers, and most data sets are too big and bulky to carry around. It's very difficult to just hand somebody a big book of data and have them really understand it. So we need some ways of summarizing it. We essentially summarize data in three ways: measures of center, measures of spread, and distribution. So we'll be discussing those three issues. The first one is measures of center, and like I said, the measures of center answer this question: what is the mediumest number in the list? In other words, a measure of center is a one-number summary of a long list of numbers. If you had to summarize this list with just one number, what would be a good number to pick? So the data that we'll be using for our demo will be this very short set, 3, 3, 6, 9, 30. I've drawn a histogram or bar graph of that here. You can see the numbers 3, 6, 9, and 30, which are drawn out more or less to scale on the x-axis. You'll also notice that the 3 bar is twice as tall as the others because 3 appears twice as often as the others. So there are basically 4 ways to answer this question. What is the mediumest number in the list? And all those words begin with M, which makes it nice and easy to get them confused. But you shall not. That is the first commandment of statistics. You shall not confuse the mean, median, mid-range, and mode with one another, because the GRE tests you heavily on how they're different. So let's take a look at each one of them in turn. The mean is also known as the average. Now on the GRE exam, they actually word it this way. They call it the average, and then in parentheses, arithmetic mean. When you see that phrase, you can ignore the word arithmetic. It means something, but you don't need to know what it means. How do you calculate it? A mean or average is something that you all probably learned in about 5th grade. It means when you see a list of numbers like this, you can add them all together and then divide by how many there are. I write that as a formula: mean equals sum over count, to emphasize that it's a fraction. That's important. We'll talk about that later. The visual interpretation of a mean on a bar graph is the balancing point. So let's practice that here. The mean of 3, 3, 6, 9, and 30. We know that the mean is a fraction. And on the top of this fraction, we're going to add these numbers together. 3 plus 3 plus 6 plus 9 plus 30. And then we're going to divide by 5 because there are 5 numbers in the list. And when you add those numbers together, you get 51. When you divide that by 5, you get 10.2, 10 and a fifth. So you'll notice that 10.2 is not actually a number in the list. It doesn't have to be. But believe it or not, you could summarize, if you could summarize this list with one number, 10.2 would be a pretty reasonable summary, because you could pretend that all these numbers are 10.2 and they'd add up to 51. Okay, now visually, again, the mean means balancing point. So if you can sort of visualize that all of this is like a lever and you need to put a balance point on it, a fulcrum. Where would we put that fulcrum in order to balance the lever? You would put it at 10.2. So you can see that most of the weight, so to speak, of the distribution is over here, and we have not as much weight over here, but it's really far away, and you know that when you push things farther away, it tends to tip the balance in that direction. So in order to make all this weight equally balance out, we would put the balance point right there at 10.2, and that's the mean. All right, what is the median? The median is also known as the 50th percentile. It means 50% of the way through the list. So therefore, the way we calculate it is the middle item in the list. So the easiest way to calculate the median is to look at the list without worrying so much about its sense of scale on the number line, and just think about it as a list of numbers from small to large, and you're going to highlight the middle number in that list. So in this case it is 6, because there are two numbers to the left of 6 and two numbers to the right of 6. That's how you know you found the median. The median also has a visual interpretation on this graph, and that is that it cuts the area in half. So let's visualize dropping a line right down the middle of this 6. Okay, so there is our median at the 6. And now I want you to think about the two-dimensional structure of this bar graph, because we're talking about area here, two-dimensional. So look at the area to the left of this dashed line. The area of this bar is 2, because it's 2 units high, and then half of this bar is to the left. So the area to the left is 2.5. Now look at the area to the right. 1, 2.5. Okay, so there's a total of five numbers in this list. Basically, 2.5 of them are to the left of the median, and 2.5 of them are to the right. Mid-range. The mid-range is probably the least well known, the most obscure of these four measures. And as a matter of fact, the GRE does not use the word mid-range. However, I find it to be a very helpful tool, and we are going to use it, especially in GRE 2 class, if you continue studying with me. But let's understand what the mid-range is. The mid-range is calculated as the mean of the min and the max. It's also visualized as the midpoint of the min and the max. So we really only need to look at the minimum and maximum values in the list, which in this case is 3 and 30. And we could therefore ignore everything in between. Just think about the 3 and the 30 and their average. So sometimes it's very easy to just look at the number line and say 3, 30, what number is exactly halfway between them? In this case, it's actually kind of hard to do. So what we can do instead is just average them. We'll add them and divide by 2. So it's the mean of the min and the max. It's 3 plus 30 divided by 2. 16.5. So what that ends up being, the mid-range ends up being this midpoint here, which is exactly the same distance from 3 as it is to 30. Another nice way of calculating this is to ask yourself these questions. If you wanted to go from 3 all the way to 30, how far would you have to travel? Answer, 27. If you wanted to go from 3 only halfway to 30, how far would you need to travel? Answer, half of 27, 13.5. So 3 plus your 13.5 would give you 16.5. That agrees with what we got here. And the fourth M word is mode. The mode is the most frequent number. And if you look at this list, you can see that obviously the most frequently repeated number is 3. And visually, it's the highest point on the graph. The 3 is the tallest rectangle, and therefore it is the mode. So there you have it. We've mapped out all the M words for this data: mode, median, mean, mid-range. Each one of them has a different calculation. Each one has a different visual interpretation. And as you can see, they can all end up in different places. Keep in mind that these numbers are all measured on the x-axis. They are all horizontal numbers. They increase from left to right. A lot of students would say the mode is up here, No, it's not up here. It's right here on the x-axis. It's 3. So remember that the measures of center are always on the x-axis. Don't try to compare them to each other vertically. Here's another point to keep in mind. For any two numbers, the mean, median, and mid-range are all the same. So the reason this is important is because sometimes the mean is very easy to calculate while the median or the mid-range is very difficult, or vice versa. So you are free to choose whichever one is the easiest to calculate if you're looking at a list with just two numbers in it. For example, here's a problem that you should be able to answer very quickly in your head in about 1 second if you know this secret. And if you don't, then it's going to waste a lot of your time. What is the average of 1,248,108 and 1,248,110? Now, if a student is not thinking very elegantly, they see the word average and they say, oh, I'm going to add these numbers together and then divide by 2, which is fine. You'll get the right answer, but it's going to waste a minute. Think about this a little more smartly. Since there are only two numbers in this list, their mean is the same as their mid-range, which is the number halfway between them. Well, wouldn't that be 1,248,109? Of course it would, because 9 is halfway between 8 and 10. So it's very, very easy when you think about it as the mid-range instead of their mean. Let's try this problem, which kind of does the reverse. What point is exactly halfway between 3.6 and 9.1, the midpoint between them? Well, that's a lot harder than the midpoint between 8 and 10, so you probably can't visualize that on a number line. However, we know that the midpoint is the same as their mean, so we could just do 3.6 plus 9.1 divided by 2. 12.7 divided by 2 is 6.35. Or this question, what is the median of the list 4, 5? And that almost doesn't even seem defined because median means middle of the list, and in the middle of this list is just a blank spot, a comma. However, we remember that the median in this case would be defined as their midpoint, mid-range. So what's exactly halfway between 4 and 5? Of course, it's 4.5, 4.5. If you added these numbers together and divided by 2, you'd also get 4.5. Here are some examples for you to try out. I've given you a list of numbers here, and if you'd like, you can pause the video and practice calculating the mean, median, mid-range, and mode for that list. And I hope these are the answers you got, because they're the answers I got, and I believe they are correct.